Hello students, in today's session we will see how to solve questions on Kirchhoff rule. Let us see one example. When internal resistance of a battery is given, let us see that illustration. Just a minute. Let us solve this numerical. This is 8-volt battery, 1 ohm internal resistance, 12-volt battery, 1.5 ohms internal resistance, and this is 9 ohms. So let us say the current here is I1, this is I2, this is I3. Okay, so the thing is, first whatever current is coming out will flow in, whatever is flowing in will come out. Current in will be equal to current out. Now you just mark the internal resistance here. Now we will mark the polarity. Remember, while writing the polarity, the current flow direction should be considered. So this is the resistance. The current is flowing in this direction. So this is plus and this is minus. Current always flows from higher potential to lower potential. So in the battery, the smaller line indicates minus and the bigger line indicates positive potential. So this is minus, this is plus. So because the current, let us say at this junction, what is happening is I3 current is branching out into I2 and I1. We have to solve I1, I2, I3 in the question. So the first equation what we are getting is I1 is equal to I2 plus I3. I3 is equal to, so if you take this joint, it is I3 is equal to I2 plus I1. So this is my equation 1. We need 3 equations to solve these 3 unknowns. So let us start marking the uh, loops. Okay. Now you just draw this internal resistance, and because the current flow direction is like this here, so this is plus, this is minus. Here it will be plus here, minus here. And this current is flowing like this, so plus here, minus here. Just remember this. If the current is flowing like this is plus, this is minus. If the current is flowing like this is plus, this is minus. Simple. Then let us take our loop. We will take in this direction A, B, C, F, A, C, F, A. Okay. So start from here. We are encountering a battery. We are going from plus to minus. So it is minus 8. And current direction is like this. So minus to plus. So plus, there is a potential rise. So current is I1, potential this resistance is 1. So V is equal to IR, no? So 1 into I1. So it is I1. Why I have taken plus? Because we are moving from minus to plus. Then we will come to the joint C. Then we are moving like this. Now the current here is I2. I2 means plus to minus, minus 1.5 into I2. 1.5 into I2. Then we are crossing a battery. It is minus to plus. So it is plus. And again we are going back to the point A. It is equal to 0. Actually, when you are starting from point A, the potential here, let us say it is VA. And when you come back to the same point, the potential becomes VA. So this both VAs will be cancelled, and finally you get 0 here. Because this is a conservative field. So in conservative, this is a conservative forces, no? So it is path independent. It does not matter you went like this or went like this or went like this. The conservative, because it is conservative, the potential remains same. So here we need to simplify this now. So I1 minus 1.5 I2. So minus 8 plus 12 plus 4. So when it goes the other side, it becomes minus 4. Okay. minus 8 plus 12 plus 4, other side minus 4. So we want another equation now. So this time we will select the second loop. See students, here the direction does not matter. Whether you take clockwise or anti-clockwise, you will get the same answers. So now we will take the second loop. We are taking a closed loop FC D E F. So here I'm starting from here, you're crossing the battery, plus 2 minus, minus 12. Then minus 2 plus, current is I2 and resistance is 1.5. So it is 1.5 I2. Then you reach a C, then here there is no resistance. Always remember, the potential at C and potential at D is same because in between there is no resistor. So if you draw a wire like this, if there is no resistor here, if the potential is A here, it will be A here. But if you draw a resistor here, it won't be A, it will convert into B. So there will be a potential difference created. How much means this current multiplied by the resistance. So minus 12 plus 1.5 I2. So we have come over here, minus 2 plus, put plus, and 9 into what is the current? I3. So 9 into I3. Then you have gone back to the point F, so equal to 0. So let us simplify this. So 1.5 I2 plus 9 I3 is equal to 12. This is my equation 3. So we have to solve for I1, I2, I3. We can take I3 and substitute here. Then we will have two equations, I1, I2. So I am putting 1 into 3. You are putting 1 into 3. What do you get? 1.5 I2. I am directly writing the values. 9 into I2 plus I1. So this is 9 I2 plus 9 I1 is equal to 12. So after simplifying, this becomes 9 I1, 1.5 plus 9, it is 10.5 I2 is equal to 12. This is my equation 4. So we have to solve I1 and I2. So we will take this equation and this equation. Simply we can do one thing. We can multiply this with 9. You multiply 2 with 9. What do you get? You get 9 I1 and you get minus 13.5 I2 and you will get here 36. This is my equation 5. So take the difference of 4 and 5, I1 will be eliminated. Okay, so I1 will be eliminated. We are taking 4 minus 5. So 10 minus of minus 13.5. 10 minus of minus 13.5 means it will become 23.5. Right? I2 is equal to, sorry, there is a 10.5 here. So this will become 24. This will become 24. So 12 minus of minus 36, this will become 48. So I2 became 2 amps. This plus indicates that whatever direction we have assumed is correct. The direction is as shown in the diagram. Now you got I2. You take this and put it over here. You get the value of I1. So I1 minus 1.5 into 2, it is 3, is equal to minus 4. So I1 is equal to minus 4 plus 3, it is minus 1. So I1 you are getting as minus. So this direction what you assumed is wrong. Actually I1 is flowing like this. Okay. Now let us find the value of I3. See, while you are finding the value of I3, whatever direction you have assumed initially, that only should be taken into account. Like I2 is 2 and I1 how much you got? Minus 1. So plus of minus 1. Here you should not change. So it is 1 amp. So you can see here I3 is 1 amp, I1 is 1 amp, and from here 2 amps is coming. So at this joint it is justified, right? At this joint it is justified, and here 1 amp is coming. So 1 amp, and here oh no, because we are considering the direction, no? Sorry, if you are considering the direction, you should take it as plus. I1 you should take it as plus. Okay, so I2 how much we got? I2 we got 2. Okay, so this is 2 and this is 1. See, I1 value is plus 1. I1 I2 is 2 amps, So if it is 2 amps, then so we will put it over here. Direction problem is we have to satisfy the KCL also, no? So let us wait and see. So I2 is 2 amps, so I3 is equal to 2 plus, what is I1 we got? I1 we got how much? I think I erased it. So I2 is equal to 2, so 1.5 into 2, 3. So I1 minus 3 is equal to minus 4. So I1 is equal to how much? Minus 1. So minus 1 indicates that it is like this, and 2 is coming like this. If 2 is coming like this, and 1 is going like this, so what is this current? So we have current in is equal to current out, right? So what is the current in? Current in is 2. Current out is 1 plus this I3. So I3 will be equal to 1. So I3 will be equal to 1 amps. So here 1 amps is coming, and then it is not getting satisfied here. I3 is 1 amps, so 2 is coming, 1 is going like this, 1 is going like that, and here 2 is coming, from here 1 is coming, so 2 going like this. Acha, this direction has to be reversed now. It is going like this, we have taken like this, it is going upward, so upward means it will go like this, and this will be reversed. So what is the answer means? Here 1 is coming, 2 is going like this, and 1 is joining here. Okay, so the figure is like this. Here 1 is coming, here 1 is coming, and 2 is going. So what are the final answers? So this is 2 amps, this is 1 amp, and this is 1 amp. This is how we solve the problem.